Hi dear friends, myself Bahusab Sononi, Assistant Professor, Department of Chemistry, Gokhale Education Society's Arts, Commerce and Science College, Jawar, District Palagar. Dear friends, in the previous part of the lecture, we have discussed about the GM counter used for detection and the measurement of radiations or the particles emitted by radioactive element. Dear friends, in that lecture, we have discussed that the GM counter particularly works on the principle of formation of ion pairs due to alpha and the beta radiations. At the same time, the GM counter is also having some limitations or the drawbacks, which is overcome by means of an next counter that we are going to discuss in this part of the lecture, scintillation counter. So today in this part of the video we are going to discuss about the second type of the counter or the instrument used in order to identify and the measurement of type of radiations emitted by the radio element, which is entitled as scintillation counter. So dear friends, today in this part we are going to discuss about the scintillation counter. This scintillation counter, it was discovered by means of scientist who is known as H. Kalman in the year of 1947. This scintillation counter, which is one of the important, just like the GM counter, it works on the principle that whenever the nuclear radiations are incident on the surface of some material, that materials are called as the phosphor. So what is phosphor, that we will discuss in the working or the experimental setup of this scintillation counter. But here simply think is that nuclear radiations emitted by a radio element incident on the surface of phosphor, that phosphor may be zinc sulfide or it may be barium platinum then these radiations which incident on the surface of phosphor, they produce a flashes of light. This is very important. That is, nuclear radiations incident on the surface of phosphor, but these nuclear radiations are emitted by the radio element. So nuclear radiations emitted by radio element incident on the surface of phosphor, then they produce a flashes of light, and these flashes of lights are called as the scintillations. That's why this counter is called as a scintillation counter. And these scintillations are used to count a pulse of current with the help of photomultiplier tube and the electrometer, which is one of the part of this scintillation counter. And from the pulse of current we will be able to identify, we will be able to measure a type of radiations or the type of particles emitted by radio element. So GM counter particularly works on the principle of formation of ion pairs, while scintillation counter works on the principle of formation of scintillations, that we call it as the flashes of light. So this is the main difference between the GM counter and the scintillation counter, and it was one of the reason due to which the GM counter was not able to use in identify and in measurement of gamma radiation, because gamma radiations was not able to show ionizing power, it was not having ionization power. But here this scintillation counter works on the principle of formation of flashes of light, that we call it as scintillations, and these scintillations are used in order to count, in order to measure the type of particles emitted by radio element. So next that we are going to discuss, so this is the experimental setup. So this experimental setup, this is the total experimental setup of the scintillation counter. Definitely this is the image that in the book you will find the different image, but not too much. So actual setup will be identical, actual setup will be same, and I have taken this image of the scintillation counter from the instrumentation tools from the Google. So I have with the help of this image I will be able to simplify this scintillation counter very well. So I have taken this. So dear friends, In order to discuss the construction or the experimental setup of this scintillation counter, it is necessary to understand, it is necessary to know what are the different components of the scintillation counter. Here in the principle we have discussed about the terms, we have read one terms phosphor. So this much part it is containing phosphor. What is phosphor, that we'll discuss. But first of all, I would like to tell you the various components of the scintillation counter. So first component is called like the phosphor. So this is the phosphor in which the material, it may be organic, it may be solid, liquid or inorganic material is kept. That materials are called as the phosphor, and these are the radiations, these are the particles which incident on the surface of phosphor, and these particles are alpha and the beta or the gamma particles emitted by the radio element, and this is the component which is containing phosphor. This phosphor is connected to a next tube. That tube is called like the photomultiplier tube, or it is also called like the electron multiplier tube. So this electron multiplier tube or the photomultiplier tube is connected to phosphor through what? Photocathode. What is the function of photocathode, that we will discuss in the working. So this is the first component. So first component of the scintillation counter is phosphor. Second important component is called like the photomultiplier tube, and this photomultiplier tube is connected to the readout device that we call it as the electrometer. This electrometer is used to record or to count the pulse of current. So these are the three important or the main components of the scintillation counter. One is the phosphor, second one is called as the photomultiplier tube or the electromultiplier tube, and the third one is called like the readout device or the electrometer. So this is very simple to discuss the it is very simple to discuss the experimental setup of the construction of this scintillation counter. So already I told you. So this is the first component, phosphor. Already I have shown here, this is the phosphor. What is this phosphor? It may be solid organic phosphor. So it may be the solid organic compound like a naphthalene or the anthracene, which is a purely aromatic compound, or it may be the liquid compound. What is liquid compound? Liquid organic compounds like terphenyl, toluene or the xylene, that can be also used as the phosphor in the scintillation counter, or it may be the inorganic compound. Inorganic compound, sodium iodide activated by thallium or zinc sulfide or barium platinocyanide. So these components or these compounds can be also used as the phosphor in the formation of scintillation counter. So what happens? These crystals of phosphor is also surrounded by means of thin film of aluminum foil and is kept in contact with the photocathode. What is the function of this aluminum foil or the film of this aluminum foil, that we discuss in the working? But remember that the crystal of this phosphor or either of this material is always surrounded by means of aluminum foil, and it is kept in contact with the photocathode of photomultiplier tube. So this is the photocathode. I hope you will be able to identify this is the photocathode. So this is the reason, this region is called as a photocathode. So this definitely, here there is a presence of an phosphor and it is photomultiplier tube. So this crystal of phosphor is surrounded by foil of aluminum and is kept in contact with the photocathode of photomultiplier tube. This aluminum foil acts as the reflector of light. So this is a very important function of this. So it acts as the reflector of light and it reflects the light flashes to the photocathode. So this aluminum foil which is present over here, it will be helpful for the light reflection, and it will be helpful to pass this light through this photocathode. So here it will be responsible for the reflection of light, and it will provide way for the light, reflected light through this photocathode. So this is the function of aluminum foil which is used to surround the phosphor. So next component that is actually very important in the multiplication of electron after this light passing through this photocathode. This is the photocathode. So this called as a photocathode means whenever this beam of light or the reflected light will pass through this cathode, it is responsible for the ejection of electron, or the ejection of electron take place through the photoelectric effect. That's why it is called as the photocathode. So remember that. So whenever the light will pass through this photocathode, there is a formation of electron, there is ejection of electron. That's why this cathode is called as the photocathode, because this formation of electron is because of the photoelectric effect. So this is very simple. So what happens? The next component is the photomultiplier tube. This photomultiplier tube is also called as the electron multiplier tube. This electron multiplier tube is also consist of different component that we will discuss here. So this is the photomultiplier tube. So this component is called as the photomultiplier tube. Definitely this photomultiplier tube is consist of the photocathode, which is present over here, and these are the another electrode called as diode. But these diodes are having the different number, and each diode is having a different value of positive potential. So definitely this photocathode carries negative charge, but the electrons are ejected from this photocathode will move towards the diode. Why this is so? Because this diode carries positive charge, so it has the positive potential, and the positive potential of each diode is increased successively. So positive potential of this diode will be having some value, but as compared to this diode will having the higher potential, and this diode will having the higher potential than this but smaller than this, and this diode will having the higher potential. Why this is so? Because the electrons should be accelerated towards the higher potential electrode called as the diode. So this is the second component, photomultiplier tube, which is also called as electron multiplier tube. It consists of a long metallic vacuum tube in which the electrodes known as the diodes are arranged in the increasing value of positive potential, or in the increasing order of positive potential. It's very important. So it consists of a long metallic tube in which electrodes, which are called as the diodes, are arranged in the increasing value of positive potential between photosensitive cathode and the anode. So here photosensitive cathode. Where is photosensitive cathode? This is the photosensitive cathode, and the last electrode is called as the anode. So this is the anode and this is the cathode, and in between these two, whatever electrodes are there, these electrodes are called as the diode. I hope you will be able to understand. So definitely it is negatively charged electrode, it is positively charged electrode, and in between these two, the whatever electrodes are there, these are called as the diode, and these are also positively charged electrodes called as the diode. But again remember that the positive potential of this diode will be higher than this. It will be having higher potential than this, it will be having higher potential than this, and successful. Definitely that's why these electrons are moving towards this diode, from this to this diode, from this to this diode, and at last whatever anode is there, it will having the highest value of positive potential as compared to or than the potential of all these diodes. That we will discuss in the working, how these are working in the scintillation counter. So these diodes are arranged in the increasing order of positive potential between photosensitive cathode and the anode, and surface of each diode and photocathode is covered by a layer of cesium. Why these are covered by cesium? Because this layer of cesium and the antimony metal and silver oxide is again responsible, or it will is nothing but one of the having important part in the ejection of secondary electron. These diodes produce secondary electrons. So definitely whenever the one electron falls on the surface of another diode, there is a ejection of secondary electrons, so that we can say that there is a multiplication of electrons. So diodes produce secondary electron in multiples of incident electron, and hence there is amplification of photoelectric current. So this is the simple case. So each diode is responsible for the ejection of secondary electron. So whatever electrons which are incident on this diode, more electrons will be ejected from this diode. Suppose the whatever number of electrons which are incident on this diode, more the number of electrons ejected from. So this is called like the secondary electron ejected secondary electrons, and this process is called as the multiplication of electrons. So this multiplication of electron take place with the help of diode of this photomultiplier tube, and the third component is called as the electrometer. So electrometer is nothing but the readout device, and it is directly connected to the photomultiplier tube, and it measures the value of amplified current. So after the amplification of current, this current is measured with the help of this part or the component of scintillation counter. That part is called as the electrometer. So it was a simple experimental setup of the scintillation counter, which consists of three parts: phosphor, photo multiplier tube, and the third one is nothing but electrometer. So this is the construction of the experimental setup of this scintillation counter. When we will discuss about the working, it's very simple. Already I told you, when nuclear additions interact with the surface of phosphor, the flashes of light falls on the photocathode of photomultiplier tube. On the photocathode of photomultiplier tube, it means that whenever these nuclear radiations, either alpha, beta, or the gamma, falls on the surface of phosphor, the flashes of light falls on the photocathode of photomultiplier tube. So once this flashes of light falls on the surface of cathode of photomultiplier tube, what happens? There is a ejection of electron, and these each ejected electrons from the photocathode will move towards the first diode or impinges on first diode and eject a secondary or several number of secondary electrons. So here you can say, here I try to say, suppose here the one electron get ejected from the photocathode due to the flash of light which falls on the surface of photocathode. This ejected electron will move towards the diode because it is subjected for the positive value of potential, and as soon as it will fall on the surface of diode, there is ejection of more electron. That electrons are called as the secondary electrons. So all these are nothing but the secondary electrons. So here you can see, here the density of secondary electron goes on increasing because there is a multiplication of electron. Whenever this electron falls on the surface of this diode, it is again responsible to eject a more number of electron, and that's why there is a multiplication of secondary electron. So that we can see from the density of these lines. So there is a simply multiplication of electron. So here in this working, we can say, so each accelerated electrons from the surface of photocathode will move towards the diode and eject a large number of secondary electrons, or the several number of secondary electrons from the diode, and these secondary electrons, all secondary electrons will migrate and multiplied by different number of diodes. So all secondary electrons will migrate towards the diodes, where these secondary electrons will be multiplied by respective diodes of the photomultiplier tube, and at the last, large electric pulse is produced, which is measured by means of electrometer. So at the last, all the electrons will be accelerated towards the anode, which is subjected to the very high value of positive potential, and there this get discharged in the form of pulse of the electrical current, and that large electrical pulse is recorded or is measured by means of an electrometer. So definitely it's very simple to see the working of this scintillation counter as compared to the GM counter. GM counter works on the principle of ion pair formation, while scintillation counter works on the formation of flashes of light on the principle of formation of lights called as the scintillations. There again, whenever we will talk about the advantages as compared to the GM counter, then scintillation counter is very easy to operate. It's very simple to operate. Again, it has very high sensitivity towards all types of radiation, either alpha, beta, or the gamma radiation. So all type of radiations can be detected, can be measured with this type of the counter, and it has very high sensitivity. Again, it can used to discriminate between the photons of different energies, and hence the gamma rays radiations can be detected with the help of this scintillation counter, and that's why this type of the counters can be used in the gamma ray spectrometer. Definitely gamma rays cannot be detected gamma particles cannot be detected with the help of GM counter, but it can be detected with the help of this scintillation counter, and that's why these scintillation counters can be used in gamma ray spectrometer. Again, these scintillation counters are having very short resolving power, and hence these are having more efficiency, these are more efficient in fast and accurate counting of gamma radiations, particularly gamma rays. So this is very important. These are having short resolving power and hence more efficient in fast and accurate counting of gamma rays. So this is important application. So dear friends, in this lecture we have discussed about the scintillation counter, its a principle of working, experimental setup means the construction. Then we also discussed about the working of scintillation counter, and at the same time we have discussed about the advantages. I hope you got the clear idea about the scintillation counter, its a principle, construction and working with its advantages in this part of the lecture. So in the next lecture we will discuss about some applications of radio element whenever these are used as the tracers. So next part video will contain the applications of radio element. So dear friends, we will continue in the next part of the video to discuss the applications of radio element. So thank you once again.